So we've looked at several ways of solving systems of equations. Now we're going to be looking at applying those ways and deciding which method is best. So let's quickly review the methods we've gone over. We've done graphing two systems of equations. We have done substitution. And we have used elimination in really three different ways. We've done elimination by adding, elimination by subtracting, and elimination by multiplication. So the best time to use graphing is usually when you're trying to just quickly graph something and estimate it. It's not going to be the best way to give you an exact solution. As far as substitution, if one of the variables is simply by itself, such as just x or y, meaning it has a coefficient of 1 or -1, and it's easy to solve for one variable, that's when you're going to want to use substitution, when it's easy to solve for the variable. Elimination is when you have coefficients other than 1. And addition and subtraction, addition is when you have coefficients that are opposite. So if you had something like 2x and -2x, then you'd want to use elimination by addition to add those and cancel them out. If you had 2x and 2x, that's when you want to use elimination by subtraction. If you had something like 2x and 4x, that's where multiplication comes in, because you would take this 2x, multiply it by 2, and get 4x, and then you would go ahead and use elimination by subtraction. So after you use elimination by multiplying, you're going to have to use one of these other two forms of elimination to finish off your problem. So let's consider the equations 4x plus 3y equals 181, and also x plus 2y equals 94. Certainly elimination by multiplication could be used here. If we wanted to multiply that bottom one by 4, we could simply then subtract the two equations to cancel the x variable out. But I'm just going to suggest, since this is already really easy to solve for x, let's just use substitution, because we can then take this and make it x equals 94 minus 2y, and then we can take this x and put it into this equation. So we would have 4 times 94 minus 2y plus 3y equals 181. Let's distribute that 4. We're going to get 376 minus 8y plus 3y equals 181. Let's combine our like terms. We have a -8 and a 3y. So we have 376 minus 5y equals 181. Then let's subtract 376 from both sides. We get -5y equals -195. So we have -5y equals 195. Let's divide both sides by -5. We end up with y equals 39. Now, knowing that y equals 39, we can use either of these equations. I'm just going to use the bottom one, x plus 2y, or 2 times 39 equals 94. Again, I'm using this equation, substituting my y value in. So x plus 78 equals 94. Let's subtract 78 from both sides. We get x is equal to 16. So I have a point at 1639. We use the substitution to solve for that because we had this coefficient of 1 in front of the x. Alright, so let's take a look at this word problem. We have the number of cameras sold in 2000. Film cameras, 20 million sold that year. digital cameras only 4.7 million sold. As we go in the electronic revolution, film cameras are getting more and more rare as digital cameras increase in sales. Since the year 2000, film cameras have been decreasing at a rate of 2.5 million per year, but digital camera sales have been increasing at a rate of 2.6 million per year. So my total number of cameras sold is going to be what they originally sold in that year 2000. So for instance, for the film, it's going to be 20 million. And then since the film cameras decrease at a rate of 2.5 million per year, we're going to take subtract 2.5 times the number of years X from that original sale in 2000. On the other hand, we have our digital cameras, which the total number sold is going to be 4.7, and now they're increasing at a rate of 2.6 million per year X. So my equation for digital cameras is going to look something like that. Now, we can use elimination to solve this system of equations to find out the year in which the camera sold is going to be equal. We want to find where both of these equations work out for the year and for the we want to figure out what year the sales are equal. So if we use elimination, it'll be simple to simply subtract this equation, because y minus y gives us 0. 2.0 20 minus 4.7 is going to give us 15.3. Negative 2.5 minus 2.6 is going to give us 5.1x. So let's solve for x by subtracting 15.3 from either side. We get negative 15.3 equals negative 5.1x. Let's divide by negative 5.1. We get x is equal to 3. Now we can throw that 3 back into either equation. Let's just take this one right here. We get y equals 4.7 plus 2.6 times 3. Erase this stuff here. And now we'll solve for y using that x of 3 years. So we get y equals 4.7 plus 2.6 times 3, which is going to be 7.8, or 12.5 million cameras sold. But we just wanted to know the year, but it's helpful to know that that's the year that 12.5 million cameras sold. So that was a look at how to apply solving systems of equations, and you can go ahead and use any method that you prefer for any system of equations. Sometimes it's just more convenient to use a different method that we've looked at in this chapter.